All right, hello. This is day one of 5-4, which is about direct variation. This is going to be new, but it's going to be along the same lines as slope. So hopefully we should be able to follow along, especially by day two. Okay, so direct variation is a linear relationship, and the root word of linear is line. So it kind of goes along with what we've been talking about with slope. And it's a relationship between two variables written in this form, y equals k times x, and k is going to be what we call the constant of variation. It's the fixed number. So k is going to be, in this case, it's really like the slope. So in real life, if, let's say, I don't know, something costs $3 per pound, 3 would be your fixed number, your constant of variation, and we could write an equation to figure out how much it costs for however many pounds is y equals 3 times x. Okay, we can figure out that constant of variation by rearranging this equation and writing it like this. Okay, I think you'll see what I mean once we do some problems. Okay, so the first part says, tell whether each equation represents a direct variation. If so, identify the constant of variation. So again, in order for it to be in direct variation form, we need to ask ourselves, is it in y equals k times x form? Okay, if it's not in that form, because I see it as in y plus 8 equals x, can I write it in this form? So in order to do that, we need it solved for y. I need it to be y equals and then a bunch of stuff. So what we're going to do is we're going to solve this equation for y. All right, so to do that, I'm going to kind of draw our line here. So here's my equation, y plus 8 equals x. So I need to get y by itself. So to do that, I'm going to subtract 8 on both sides. So I'm going to subtract 8 here and here. Okay, so those are going to be canceling out on the left side of the equation. And I'm going to be left with y on the left side. And on the right, I can't do x minus 8 because they're not like terms. So I just have to leave it as x minus 8. So the equation looks like this, y equals x minus 8 when I've solved it for y. So is this in this y equals k times x form? And the answer is no. And the reason why it's not is because, is there some number multiplied by x? Well, technically there is. It's 1x. So it has the y equals k times x part. But this part right here, this minus 8, is kind of my red flag that makes it not in that form. Okay, so if it's got a number added or subtracted on, it's not in that form. So this is not a direct variation. Okay, so the next one is 3y equals 2x. Again, we're going to solve this equation for y. We want to get y by itself. So first thing I'm going to do is, to get y by itself on this side of the equation, I have to move the 3. 3 is multiplied by y, so we're going to divide by 3 on both sides. And that's going to cancel out my 3's here. And we're going to be left with y equals, now 2x over 3 can actually be written as just the fraction in front of the x. So we can write this as 2/3 x. Okay, so again, that's y equals 2/3 times x. So is this in that form, y equals k times x? And the answer is yes. I've got a number that's substituted in for the k, and then I have the x there. So this equation is in the form y equals k times x. So this original equation is a direct variation. The constant of variation is the value of k, the only number that you're going to see in the equation, which is 2/3. Okay, the next one says tell whether each set of data represents a direct variation, and if so, identify the constant of variation and then write the direct variation equation. Okay, so here we have price and weight. Now I don't really like this, how they really write this, because price is always a dependent variable. Price of something depends on its weight. So really we have, this is our y coordinates here, and this is our x coordinates. We usually write this out so that x is on top and y is on the bottom. So I'm just going to kind of rewrite this graph here, or this table. Because you're not really going to be seeing it written this way, okay? So switching these around, 2 is 69, 3 ounces costs $99, and 4 ounces costs $129. Okay, so to find direct variation in a table, what we're going to do is use the other formula for direct variation, which is K equals Y over X. And that's going to tell us if we have a constant of variation or not. Okay, so if I look here, we're going to use Y over X for each ordered pair. So the first one, the first ordered pair, we're going to do 69 over 2. And then we're going to simplify that. I'm going to grab my calculator here. Sorry about that. Okay, so 69 divided by 2 is 34.5. The next y over x is going to be 99 over 3. And 99 divided by 3 is 33. They wrote it like this, 33. Okay. Now already I can tell this is not the same value. So this is not going to be the same for each ordered pair, which that means the data do not make a direct variation. Okay, the third one, if I were to try that, it's 129 over 4. And if I divide those, I get 32.25. Okay, so therefore K is not the same for each ordered pair. And if you don't get the same K value each time when you do the Y divided by the X, it's not a direct variation. Okay? All right, the next one says, tell whether the graph represents a direct variation. And if so, identify the constant of variation and then write the direct variation equation. All right, so in order to figure this out, we ask ourselves two questions. Okay, so number one, is it a line? Okay, if it's a line, it might be direct variation. Okay, second of all, it has to pass through the origin. Okay, so in this case, the answer to the first part is yes, it's a line. Okay, and the second one, does it pass through 0, 0? The answer is yes. Okay, so the graph is a line through the coordinates 0, 0. So this is a direct variation. And the direct variation, the constant of variation, all that is the slope. Okay, that's important to know. So when you have a line, the constant of variation is just the slope. So we are going to count our rise over our run. Now this graph doesn't give me points, so I'm going to pick some. It goes through that origin really nicely. And then I see right here at positive 2, negative 1, it goes through an intersection nicely on the graph as well. So if I were to count my rise over my run, in this case, it's going down 1 and over 2. Okay, that is my slope, so that is the constant of variation. So the slope is negative 1/2, so that means K equals negative 1/2. So now to get the equation, we just did the constant of variation, and now we need to write the direct variation equation. Okay, the equation is in the form y equals k times x. And all we have to do to write the equation is rewrite y equals k times x, but replace the k with the k we found. So y equals negative 1/2 x is the equation of direct variation. Okay, I'm going to apologize. I'm going to skip this page if you have this in your notes. I'm going to skip that for now. Okay, so this one says, tell whether the equation 3y plus 4x equals 0 represents a direct variation, and if so, identify the constant of variation. So when it is in an equation form, we need to solve for y. Okay, I'm going to do this down here because I'm going to have more room to do that. So my equation is 3y plus 4x equals 0. So I have to solve it for y to see if it's in that form, y equals kx. So the first thing I'm going to do here to solve for y is I need to move this 4x. And I'm going to do that by subtracting it. Okay, so that is going to go away. And now I'm left with 3y on the left side. And on the right, 0 minus 4x. I don't even really need that 0, so I can just rewrite this as minus 4x, which is the same as negative 4x. Okay, one more thing I have to do to get y by itself, I have to get rid of the 3. So 3 is multiplied on, so I'm going to divide by 3 on both sides. And I'm left with y equals, now again, I can just pull the fraction part out in front, and that's negative 4/3 x. Okay, so is this in the form y equals k times x? Is it y equals some number times x? And the answer is yes. Okay, and then our constant of variation is going to be the number that's in front of the x, the k. So the answer here is yes, and k equals negative 4/3. Okay. The last one says, tell whether the set of data represents a direct variation. And then if so, we have to write the constant and the direct variation equation. So first of all, we have to find whether it is or not from a table. We're always going to start with dividing the y value by the x. Okay, so now I don't really like, again, how they have this laid out. In the notes, they tend to put the y on top of the x. The price is going to be our dependent variable because price depends on how many tickets you buy. So price is usually going to be that y value. So in this case, we're going to take all of our y's and divide by x's. So the first one we're going to try is 3750 divided by 5. And that's 7.5. Okay, and now we're going to go to the next y over x, 67.5 over 9, which is 7.5. And then we're going to try the last one, 105 over 14. And that is 7.5 as well. So they are all the same. Since they're all the same, okay, the answer to the first question is yes. Okay, they do represent a direct variation. The constant of variation is the number that we got every single time. Now, I've had some people say, does it matter if I do y divided by x or x divided by y? And the answer is, if you just want to figure out if it's direct variation, the answer is no. But if you divide them in the wrong way, then you're not going to get the correct k value. Okay, and then we have to write the direct variation equation. Direct variation equation is y equals k times x. We just replace the k with our constant of variation. So y equals 7.5x. So this would represent the amount that it costs per ticket. So for example, 5 times 7.5 would be $37.50. So it's $7.50 for each ticket. So I could use this equation to figure out how much it costs for 7 tickets or 8 tickets or 12 tickets. Okay, that's the point. Also, this would be the slope of the line if I were to graph that in a coordinate plane. All right, I know that this is not easy at first. I think the second day that we do this is going to make a lot more sense to you. So try to bear with me and let me know if you have any questions on the assignment.